I'm going to tell you about our experience working with Pattern Computer to use machines to understand biomedical systems. Now, every single one of these genes has a preclinical drug designed to hit it. What this gives you is a map from gene expression space to what you might want to do to move person A or person 1 or person 2 from the space they're in now to a space with improved prognosis.
We used very large amounts of data and then worked with Pattern Computer to find new things that we didn't really understand before. But the Pattern Computer people came back and said, Larry, we need to look at this yellow bridge set of samples, which didn't occur to me before to think about that. And what we find is that these that were selected by the Pattern Computer were discovered are associated with oxidative phosphorylation, which is a disease, actually, if you don't have enough of those proteins, and is involved in a variety of the things that are associated with disease. So summing it up, basically, there was a 1,000-fold reduction in the scale of the problem. These 9, we are now going to be able to go off. There's a hypothesis these 9 might be important.
So given where you are now and what you've just described and the dependency upon big data and finding patterns and pattern discoveries in that data, how do you see working with us?
Well, I think the point I should have made that was not clear is we do have an enormous amount of data, but in the fascinating things I've showed you here, we're just barely beginning to scratch the surface in what we can do with it. And I think you raise another possibility, especially for being able to integrate information at different biological levels, to bring us back to a network understanding of the nature of wellness processes and of disease processes.